All right, as you guys saw with Mr. Green, we're looking at solving systems, the same thing we did last week using elimination. Okay, so this is the new skill. So our first equation we're gonna look at is 3x plus 2y equals 12, and 2x minus 2y equals 8. Okay, so when I look at this problem, I notice there's something I can eliminate. So if I add these two things together, which of these coefficient and variables make a zero pair? 3x and 2x, or 2y minus 2y? I know positive 2y minus 2y really is like a zero pair, or you can write 0 here. So now I'm gonna add up everything else I have here. So I have 3x plus 2x, which I know is 5x. This is 0, so I'm not going to bring it down. And we have equals 12 plus 8 is 20. So from here, we just need to solve for what our x is. So I'm going to draw the line. I know the 5 and the x are being held together by multiplication. The opposite of multiplication is division. So we divide by 5 and divide by 5. 20 divided by 5 is 4. So I know that x equals 4. But let's think back to last week. We talked about that the solution is always an xy coordinate. So I've only solved for half of the solution right now, and that half is the 4. So now I need to figure out the y. So I have two equations. I can use this one or this one. Doesn't really matter, so I'll just use the first one. So we have 3x plus 2y equals 12. But hold up, we know right now that x is 4. So I'm going to plug that in right there. So we're going to say 3 parentheses 4 plus 2y equals 12. 3 times 4 is 12 plus 2y equals 12. Okay, so the very first thing I'm going to do here is get rid of this 12. So minus 12. Minus 12. Oh, well, 12 minus 12 is actually 0. So we have 2y equals 0, so I'm going to divide by 2. 0 divided by 2 is just 0, so our y is actually just 0. So I know if I go in and graph these two graphs on Desmos, the point they're going to cross or intersect is at 4, 0. All right, let's do one more. All right, my next equation is negative 7x plus 4y equals negative 1. And 7x minus 2y equals negative 3. Okay, I'm going to add these two together, and I'm going to look and see, okay, what is the thing that I can eliminate here? I notice that I have a negative 7x and a positive 7x. Those, when I add them together, give me 0, or create that 0 pair. So then I'm going to just add up the rest of this. We have 4y plus minus 2y, which is just 4 minus 2y, which gives us 2y. And then I have negative 1 plus negative 3. That's getting more negative, so that's going to be negative 4. So I'm going to draw my line. I notice this 2 is being held by multiplication. The opposite of multiplication is division. So we have y equals negative 2. Negative 4 divided by positive 2 is negative 2. Now again, our solution is always written as a coordinate point. So right now I only have my y. I have to go back and solve for my x. We use the first equation, so this time we'll just, the second equation, you can use either. So we have 7x minus 2y equals negative 3. But we already solved, and we know that y is negative 2. So this is actually going to become 7x minus 2 parentheses negative 2 equals negative 3. Negative 2 times negative 2 is positive 4, right? Okay, and then I have this 7x. All right, this is throwback to solving. That's why we've been practicing solving. I got to get x by itself. I have two things in the way. So remember, this is when we use reverse PEMDAS. So I add and subtract before I multiply and divide. So we have 7 being held together with multiplication and then plus 4. So I'm going to get rid of the addition first by saying minus 4. Minus 4. Negative 3 minus 4 is negative 7. Then I have 7x left here. So these are being held together by multiplication. The opposite is division. 7 divided by 7 is 1. And then we're going to divide by 7. Negative 7 divided by 7 is negative 1. So my x value is negative 1. So I know if I were to graph these two lines on a coordinate plane, they would cross right here at negative 1, negative 2. Okay?